Sugod na ta.
Problem. Solve for the power across the 6 ohms resistor. So the power across your 6 ohms resistor is equal to your power across your 6 ohms resistor is equal to the voltage at your 6 ohms resistor times current at your 6 ohms resistor, or that is also equal to power at your 6 ohms resistor is equal to I current at your 6 ohms resistor squared times the 6 ohms resistor. Therefore, by nodal analysis, let's assume that this will be your node 1 and this will be your node 2. So let us assume that your node 1, yeah, node 1 is equal to V1, and let your node 2 is equal to V2. So by nodal analysis, if we will assume that this would be the direction of your I6 ohms, then by the analysis, so analysis, the value of your I6 ohms is equal to the tails voltage minus the heads voltage divided by the resistance. So that would be at node 1, that would be V1, and this would be your V2. So you have V1 minus V2 divided by the resistance, so that is equal to 6 ohms. So this would be your current. So let's find the values for your V1 and V2. At node 1, node 1. So first let us assume that the current flowing to your 2 ohms resistor is going downward, and this will be your I2 ohms. And the current flowing at your 7 ohms resistor is also going downward, and let us denote that as I7 ohms. Now let's go back to your node. At node 1, the current entering at node 1 is 1 ampere, since this is a current supply, 1 ampere. So 1 minus the current leaving at your node 1. So you have I6 ohms minus I6 ohms minus current leaving, that will be I2. So that is I2 ohms. That is I2 ohms is equal to 0. Substituting it by its nodal current equivalent, so you have 1 minus, so that is I6. You have tails minus heads, so you have P1 minus V2, V1 minus V2 divided by the resistance value, so divided by 6. So for your I2 ohms minus, so you have tail's voltage minus the head voltage. So the tail voltage will be V1. So it's V1. Since your head is directly to the ground, so that is 0. Divided by the resistance, so you have 2 ohms, is equal to 0. Then you have to simplify the equation. So you have 1 minus negative V1 over 6, so you have negative 16 V1. You have negative times negative, so you have positive 16 V2. Negative 1/2 V1 is equal to 0. Then combine like terms. So you have 1 minus 16 plus 16 minus 1/2. So you have negative 2/3 V1 plus 16 V2 is equal to 0. And this will be your equation 1. At node 2, so the current entering at your node 2, you have I 6 ohms minus the current leaving 4 amperes minus the current leaving I 7 ohms. I 7 ohms is equal to 0. So substitute its nodal current equivalent. So for your I 6 ohms, tails minus heads, so you have V1 minus V2 over the resistance value, 6 minus 4. For your I7, you have V2 for your tails, 0 for your head, directly to the ground, divided by the resistance value, 7, is equal to 0. Simplify the equation, so you have 16 V1 minus 16 V2 minus 4 minus 17 V2 is equal to 0. So combine like terms, so 16 V1. Then you have negative 16 minus 1 over 7. So it's negative 13 over 42 V2 minus 4 is equal to 0. And this would be your equation 2. So you have now your equation 1 and equation 2. So rewriting your equation 1, transposing the constant value in the right hand side. So your equation 1 is equal to negative 2/3 V1 plus 1/6 V2 transpose is equal to negative 1. And for your equation 2, you have 1/6 V1 minus 13 over 42 V2 is equal to, transpose to the other side, we have positive 1. Solving it by Kramer's rule. So first, let's make a matrix. You have V1 column values of negative 2/3 and 1/6. Then you have 1/6 and negative 13 over 42. Multiplied by your unknowns. That is V1 and V2 is equal to, write the constant values. So you have negative 1 and 4. So we need to find the value for your V1 and V2. Values for your V1 and V2. So solving by Kramer's rule for V1, your V1 is equal to, place the value elements of your V1 by the constant values. So you have negative 1 over 4. Copy the second column. You have 1/6 over negative 13 over 42 divided by your element of the unknowns matrix. So you have negative 2/3, 1/6, 1/6, and negative 13 over 42. Then solving for each determinant. So you have 1 times negative 13 over 42. So it's positive 13 over 42. Minus the upward diagonal. So you have 4 times 1/6. So you have 2/3. Positive 2/3. Next, you have negative 2/3. Negative 2/3 times negative 13 over 42. You have 13 over 63. 13 over 63. Minus 1/6 times 1/6. So you have 1 over 36. So solve. You have 13 over 42 minus 2/3 all over 13 over 63 minus 1 over 36. So your V1 is equal to negative 2 volts. So for your V2, your V2 is equal to, substitute the constant values to your column of V2. So copy the elements of V1. So you have negative 2/3 1/6 for V2, replaced by the constant values. So you have negative 1 and 4 divided by these elements. So you have negative 2/3, 1/6, 1/6, negative 13 over 42. Then solve for the determinants. So you have negative 2/3 times 4. So that is negative 8 over 3. Minus 1/6 times negative 1. So that is negative 1/6. Negative 2/3 times negative 13 over 32. So this value is the same as above. You have 13 over 63 minus 1 over 36. So that is equal to negative 14 volts. So solving for your I 6 ohms, because now we have the values of your V1 and V2. You have I 6 ohms is equal to V1 minus V2 all over 6. Substitute the values of your V1 and V2. So you have negative 2 minus 14 over 6. So negative 2 minus 14. So negative 16 divided by 6. So negative 16 divided by 6. So that is equivalent to negative 8 over 3 amperes, or approximately equal to negative 2.67 amperes. So therefore, your power at 6 ohms is equal to I 6 ohms squared times R 6 ohms. So substitute the values. So you have negative 2.67, negative 2.67 squared times 6. So you have negative 2, negative 2.67 squared times 6. Then you have 42.77 watts. So this would be the power across your 6 ohms resistor.